Alright, hello everybody. Today we're covering section 2.4, higher degree polynomial equations. Once again, quoting from home, working from home. There may be strange noises. I apologize in advance. So we're going to talk about solving quadratic-like equations, solving general polynomial equations, solving by equations by factoring, solving polynomial-like equations by factoring. So things that can look like polynomials, we'll discuss what those are in a moment. So quadratic-like equations. So an equation is quadratic-like or quadratic in form. We can be written in the form of where we have a, so we have some leading coefficient, could be 1, something squared plus b times that same something to the first power, and then c, our constant, equals 0. Now, b and c could be 0, but a cannot be, otherwise it wouldn't have that like quadratic form. And u is some algebraic expression. So it could be in parentheses, it could be something that's already squared out, or something that's squared out here. For example, we have x squared squared, so that'd be x to the fourth, minus 2x squared. So x squared squared, so this quantity squared, leading coefficient would be 1 in this case, and then something to the first power. So this would be the part that's to the first power. So you got the square here, first power, and a constant. We choose our u, in this case our capital U, to be x squared. So now we have the equation u squared minus 2u plus 1 equals 0. To solve this equation in the form, we first solve for u, and then we solve the variable and the expression for u. So the equation above, we'd get u equals 1. And then for the final answer, we would get x squared equals, we'd solve for the final answer, x squared equals 1, which would be x equals plus or minus 1. I have two answers for that one. Even though there's a possibility for, we'll talk more about that here in a moment. Is it focusing well? Alright. So we want to solve for x in this one. So let's make it look like a quadratic. It'd be easier to look at. So let's say we have a, capital A, equals x squared minus 2. And the mistake I see a lot of students make if they don't look at the notes first or practice first is that they'll factor this all out, or they'll multiply this all out, and then they'll try to factor it, and it'll be to the fourth power. It'll look pretty intimidating, so I encourage you not to do that. So I'm going to have a squared plus 7 to a to the first, and then we have minus 18 equals 0. So that's going to give us, we need two numbers, so we go over here in our factors of 18. We have 1 and 18, we have 2 and 9, we have 3 and 6. I'm looking for a difference, because this is a negative, whose difference is going to be 7. So two of these numbers whose difference is 7 is going to be 9. We want positive 7, so we want the 2 to be negative. So we'll go over here. The only way I can get a is a times, or a squared is a times a. Then I'm going to get I'm going to get a negative 2 and a positive 9 equals 0. Once again, we can see that each one of these we can multiply back together and make sure we get our middle term and our last term when we undo the FOIL. Once again, if you have trouble with factoring, go back to my lecture in 2.3. Attempt the homework there. Be very familiar with factoring. It'll be a key component of things I work through for the remaining of the semester, and other math classes above this class as well. Factoring is just something we assume that everyone can do past this point. If you can't, we are more than happy to help you out, but we cannot help if you do not let us know. Alright, so this is, I actually need to set each factor equals 0. I kind of skipped the middle part here, or combined my parts here. And so I have a equals 2 and a equals negative 9. So that means that actually over here I have a portion, I have a part of my, where I have x squared, because this is my a, right? This is a. And now I'm going to set that equal to 2 first. So I'm going to get x squared. And if I add 2 to both sides, x squared equals 4. So that means x equals plus or minus 2. Once again, I just took the square root of both sides. When you take the square root, you have to have a plus or minus. I'm going to do the 9 now. So I'm going to have an x squared minus 2 equals negative 9. All right, so I'm doing this portion right here. And that's going to give me x equals, and I'm going to add 2 to both sides again, 7, or x squared equals 7, negative 7. So that means x equals plus or minus the square root of 7. Now, this is negative 7, so actually I need there to be an I here if you want to do it, and make sure that you do all the steps in order correctly, is that you take the square root of x squared, and when you do that here, you take the square root plus or minus of negative 7, so that means you're going to get x equals plus or minus, and then you have to have I square root of 7. So that negative 7 became, the negative underneath the radical became the I out front. And so here, you'll notice how many answers do we have. If you write this out in Hawks, they're going to say, put an answer in each answer blank. All answer blanks may not be used. You're going to have a 2, a negative 2, a negative I square root of 7, and a positive I square root of 7. So you have 4 answers. And the reason why we can have up to 4 answers is that when you have these being nice whole numbers, you can get as many different answers as you have powers of x. So this would be x squared squared, which would be an x to the 4th power. So we could have up to 4 answers. Some of those answers may be repeated. We'll talk more about that later. And when you have fractional exponents, well, a lot of silly stuff can happen. It's not necessarily guaranteed you'll have more or less answers. We'll talk more about that here in a moment. But the standing rule for this is a whole number. The highest power that you have that's a whole number, you can have up to that many answers. For fractions and rational expressions, it could be any number of things. Alright, so here we have solve for x again. The easiest thing to do here is let our a be x squared, because this is basically, you look at the middle term and what that is. Yeah, that's going to tell you what you need to be a here. And so we're going to get a squared plus 5a minus 3. Now I know some students will skip this step and they'll just say ax squared squared plus 5x squared minus, or squared on the inside, excuse me, minus 36, oh, it's a 3, equals 0, and they'll just work it out that way. Either way is fine. I'm going to do a because I think when walking through this or going through this first time, most students appreciate that best. So looking at this, we're going to get a, I need 2 things that have a difference of 5 multiplied to give me 36, so 2, and that's going to be 18, 3 and 12, it's going to be 4 and 9, and it's going to be 6 and 6. As we can see, 4 and 9 have a difference of 5, so I'll pick those. So let's say a, and they need to be, the 9 needs to be positive, 4 needs to be negative, so minus 4, and then that's going to be a plus 9 equals 0, so I'm going to get 2 answers. A could be, and you can just look at this and examine that this leading coefficient's 1 right here in front of the a. You say a could be 4, or a could be equal to negative 9. So just by examination you can tell that. If you need to set each factor equal to 0 and solve, that's fine too. You'll get the same thing. So we're looking at what a was. So for this first portion, let's say a is equal to 4. So I'm going to say that we had x squared is equal to 4, so x would be plus or minus 2, and then we're going to have x squared was equal to 9, so this would be this portion, this would be this portion, and so that means x equals plus or minus, and this is where the I comes in, 3i, because I took the square root of a negative number. Once again, combine my steps. If you need the intermediate step, and then you go to here. So we have 4 answers for that one as well. Plus or minus 2, plus or minus 3i. Alright, so this one's a little bit more interesting because when it's not clear how many answers you have when you have fractional exponents. You could have 1, you could have 2, you could have a dozen. It's hard to picture that ahead of time. But here, this one is still reducible to quadratic form because I realized that this middle term I'm looking at here is this term's this variable right here is squared right here. So I could say that my a in this case is going to be is going to be x to the 1/3. So now I'm going to get 3a squared plus 20a plus 12 equals 0. So now this is a little bit more intense because I have to find the factors of 3, 1 and 3, and the factors of 12, which would be 1 and 12, 2 and 6, 3 and 4. And so I need the factors of 3 and the factors of 12 that will add, because I'm looking for a sum to give me 20. So I'm going to have 1 and 3 right here. So these are my factors of 3. And then I'm going to put my factors of 12 here, and I'm going to say, all right, what would get me close to 20 as a sum? Well, if I had 3 times 6, that would be 18. And if I had 1 times 2, because it's my other factor. So these are my factors of 3, these are my factors of 12, and 1 times 2 is 2. And you add those together, you get 20. Once again, you can do it by AC method and say I'm looking for the factors of 3 times 12, which is going to be 2 times 12 is going to be 36. The factors of 36 that will add to give you 20 would be, I'm trying to think of this off the top of my head, would be 2 and 18. Those will give you 20. And you could do it that way as well. AC method worries you, don't worry about it. Or confuses you, don't worry about it. So looking at this, I'm going to have 3a, and that needs to be paired up with the 3 needs to be paired. So I need 3 times 6. So 6 needs to be over here. And that's going to be positive. These are all positive because these all signs are positive. And then I'm going to have the 1 and the 2 need to be paired, or the 1 needs to be multiplied by the 2. So I need the 3a plus 2 here is equals 0. So we're going to have my a, so 3a plus 2 has to equal 0, or 3a has to equal -2, or a has to equal -2 over 3. And that's what x to the 1/3 is equal to. And then over here we have a plus 6 equals 0, so a equals -6. So that means x to the 1/3 actually equals -6. So I have two options. X to the 1/3 can equal -2 over 3, or x to the 1/3 can equal -6. So that in mind, I'm not done yet. I need to cube both sides. So remember, if we want to do a root, I'm going to have to cube it to that amount. So here I'm going to cube this. So I cube this top and bottom, and I'm going to get, let me just write it over here. I'm going to get x equals -8 over 27, because that's -2 cubed and 3 cubed, which is 27. And then over here, I'm going to get, and I cube both sides, I'm going to get x equals -216 when I cube both sides here. I have to raise to whatever power undoes the root. In this case, the cube root, so I raised it to the 3rd power. So these are my two answers. I only have 2 answers for this one. Like I said, it can be hard to tell when you have fractional exponents what you should get back out. Alright, next, looking at the following. So here everything had 3 terms, so it was a trinomial, or could be looked at as a trinomial. Here I have 4 terms. Even anytime you have an even number of terms and somebody tells you should factor it, or you're dealing with something where factoring would be useful, you always try factor by grouping, because if it's an even number of terms, you might be able to factor something out for us. Now, granted, if you had something like, you could factor by grouping and have an odd number of terms, but usually that's much higher on, and you're factoring out an odd number of terms. But here we have an even number. We'll probably just stick to this. Y to the 3rd plus 3y squared minus 16y minus 48 equals 0. So now that we have this, we're going to say, well, I want to look for something, so factor by grouping. So I'm going to factor out the biggest thing I can from these 2 terms and the biggest thing I can from these 2 terms. So y squared is in common to both those terms. So I'm going to factor out a y squared, and that's going to give me y plus 3. And here, the biggest thing I can factor out is 16. 16 goes into this number, 16 goes in that number. But not only that, I'm going to factor out a -16. Why do I want to do that? Because when I factor that out, I'm going to get y. -16 goes into -48 3 times. And the reason why I wanted the negative out is so these terms be exactly the same. I'm going to continue. I'm going to factor the y plus 3 outside. And then I'm going to have y squared minus 16 equals 0. So that means I'm going to get y plus 3. And this is y squared. So you can do one of two things. You can set each of these equal to 0. You can factor further. If you notice there's a difference of two perfect squares, you could say this is y plus 4, y minus 4 equals 0. And then you'd say that y can equal negative 3. It can equal negative 4, or it can equal positive 4. Another way of looking at this is you could say y equals negative 3 and y squared equals 16, so y would equal, so this is the first portion, this is the second portion, plus or minus 4. You get the same answer working either way. Alright, so here's probably the interesting type of problems. Once again, fractions are our friends, don't let them worry you. What we want to note real quick is that 7/3 is actually 2/3, which is actually 2 plus 1/3. All right. And the reason why this is noticeable is we'd want to note this, is that if you look here, all these have an x term in common. If you see something has an x in common, factor that out. What's the highest power of x we can factor out? The highest power is x to the 1/3. Well, what do we leave behind? In this case, we'll have an x to the 7/3, and when you factor something out, it's like minusing from the exponent. 4/3 minus 1/3. And then we can even do this last term here, even though that's the term we factored out. So now that I've factored out something, it's like I'm subtracting from the exponent here, because I'm factoring, dividing. And then that's going to give me x to the, what was that, 6/3 plus x to the 3/3 minus 2 to the x to the 0 power. Equals 0. Anything to the 0 power, x to the 0 power equals 1, because we assume x doesn't equal 0, because if it equals 0, then we couldn't, well, then it'd be obvious, well, x can be 0. I'll take that back, excuse me. That possibility is handled by this set right here. So with that, we have the following. And so we have x squared plus x to the first, we don't need that first there, minus 2 equals 0. So I'm going to factor this as well, x to 1/3, and then I'm going to say two things that multiply to give me negative 2, which is 2 and 1. It's going to be positive 2, because my middle term is positive, x minus 1. So my FOIL, my last term, is negative. And then I'm going to set each of these factors equal to 0, so I have x to 1/3 equals 0. Anything with an x has to be set equal to 0. So that's going to give me, if I cube 0, whoops, I'm cubing, not taking the cube root of. If I cube 0, I still get 0. That's going to be x equals 0, x equals negative 2, and x equals 1. So I have three answers there. So this is something that looked like a quadratic that had three answers. Why did it have three answers? Well, fractional exponents are really hard to see what you're looking at. Don't think you're supposed to have 3 or 7 answers because you have irrational exponents. That's only when you have a whole number you can have up to that many answers. But that is our last example for this lesson. Strongly suggest you go back to 2.3 if you're having trouble following along. Spend some time with this lesson as well. It's got a lot of factoring problems in it that'll help you master stuff from 2.3, because anything I tell students, they say, what do I need to know when I take algebra? I'm like, if you know how to factor, especially when the leading coefficient is not equal to 1, factor by grouping, factoring things that look like quadratics, it will help immensely, especially if you can do that. Not in your head, but with a little scratch paper, a little work, you can get it done pretty quick. You should be set. All right. Thank you for listening. Y'all have a good one.